This is the intro to section 7.2, part 1. And in 7.2, we're going to start talking about similar polygons, and we're going to talk about similar triangles and different similar shapes. And these are going to be a little bit different than what we've looked at before. Okay, so our objective here is to identify and apply similar polygons. What are similar polygons? Similar polygons are similar polygons if their corresponding angles are congruent and their corresponding side lengths are proportional. So, it's different to be similar than it is to be congruent. If you're similar, you look like you're the same shape, but you're different sizes. Okay? So, in this case, we can add this in here. We are same shape, different size. Okay, same shape, different size. Now, one thing that's important about two polygons that are similar is what we call the scale factor. If two polygons are similar, then the ratio of the lengths of the two corresponding sides is called the scale factor. Now, ratio is another word for fraction. Okay, so I can write the fraction of the corresponding sides, and we can create what we call a scale factor. Okay, now we're going to look at that, and we're going to talk about that here in the first question. It says, given that triangle PQR is similar, this symbol right here is the similar symbol, little squiggly line, to triangle XYZ, list all pairs of congruent angles, then write the ratios of the corresponding side lengths in a statement of proportionality. Okay, so first thing I'm going to do here is we're going to identify the congruent angles. Well, we can talk about the angles first because they're pretty easy to find. In this case, we know that angle P is congruent to angle X. Again, you're matching up sides that are corresponding. Angle Q is congruent to angle Y. And angle R is congruent to angle Z. Okay, the corresponding angles are still congruent. All right. Now, the corresponding sides are proportional. So what I can do is I can write it as a fraction. So I'm going to start with the first two letters, PQ, and I'm going to put that over the first two letters of the other shape, which is XY. And that has to be equal to the next two letters, which is QR, which is letters 2 and 3, which means I have to look up here and see letters 2 and 3, which is YZ, and that's going to be equal to RP over ZX. Now, instead of saying corresponding sides are congruent, again, corresponding sides are proportional. Okay? Now, this fraction that you're going to get, once it is reduced, becomes your scale factor. Okay, this is also the statement of proportionality. That's what this is called right here, the statement of proportionality. All right. So once you figure out your proportions or your fractions that you set up, your ratios that you set up, okay, a proportion is where you can set up two fractions equal to each other, two or more fractions equal to each other. So we're talking about proportions and we're talking about ratios, and a ratio is a fraction. So when we are able to make the corresponding side lengths proportional, we reduce that fraction and it becomes our scale factor that we have. Okay, these are the types of things that they're going to have you do here. Okay, here it says use the similarity statements. Using similarity statements. In the diagram, ABC is similar to DEF. List all pairs of congruent angles. Check that the ratios of the corresponding side lengths are equal, and write the ratios of the corresponding side lengths in a statement of proportionality. Okay, so take a chance here, hit pause, and see if you can figure this out on your own before I go through this. Okay, now that we're back, let's take a look now first at the angles. we know that angle A is congruent to angle D, and we know that angle B is going to be congruent to angle E, and angle C is going to be congruent to angle F. That's the easy part. The angles are always going to be easy. Okay. Now, check that the ratios corresponding side lengths are equal. So we have to set up our proportions. So again, I'm going to set up AB is the first two letters over the first two letters of DE. Has to be equal to BC, which is the 2 and 3, over 2 and 3, E and F, which has to be equal to then CA over FD. Okay, now what I'm going to do is I'm going to match up the side lengths up here with the sides. So side AB is 10, side DE is 15, is equal to side BC is 8, and side EF is 12, and side CA is 12, and side FD is 18. Okay? So now what I have to do now is reduce these fractions to see if they're all the same. If they're all the same, then these two shapes are similar. If they're not all the same, if they reduce to different numbers, then these two shapes are not similar to each other. Well, 10/15, 5 goes into both of those, and this reduces to 2/3. 8 and 12, 4 goes into those, and that reduces to 2/3. And 12/18, both of those are divisible by 6, which also reduces to 2/3. So these are all the same. Okay? These are all the same. So yes, these are similar, and my scale factor is 2/3, or 2 to 3, as they would say. Okay, determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor of ABC to JKLM. ABCD to JKLM. Now, you don't know that these are similar, so we're going to have to actually show that. Okay? So in order to show that, we need to first of all show and see, are all the corresponding angles congruent? Well, as you look at your picture here, A and J are the same, B and K are the same, C and L are the same, D and M are the same. So all the angles match up. We're halfway done. Second thing we need to know is our statement of proportionality. Will our scale factor be exactly the same? So we've got AB over JK would be equal to BC over KL, which is going to be equal to CD over LM, which is then going to be equal to DA over MJ. So now I'm going to substitute my numbers in. When I substitute my numbers in, I've got AB is 8, JK is 14, BC is 8, KL is 14, CD is 8, LM is 14, and DA is 12, and MJ is 21. Okay? All right, now, as you're looking at this, we have to figure out, is the scale factor the same? So these all need to be reduced. Well, these three are all reducible by 2. I'm sorry, yes, by 2. So these guys are divided out by 2. That's 4/7. Those are all the same so far. And this last one, the biggest number that will go into both is, as we look at it, is 3. And if I divide them both by 3, that gives me 4/7. So all of these are the same. So I know, since my scale factors, or my statement of proportionality, are all the exact same, I know that A, B, C, D is similar to J, K, L, M. Okay, and my scale factor happens to be 4/7, or 4 to 7. Okay, let's take a look at this last one. Again, hit pause and see if you can calculate this last one as we go through. It says in the diagram, triangle BCD is similar to triangle RST. Find the value of X. Okay, now that you've hit pause, let's take a look at these examples here. Now I'm going to have to set up a statement of proportionality if I know they're similar. So I know that BC is the same as RS, and I know CD is in the same position as ST, and I know that DB is in the same position as TR. And if I put their values in, I end up with 12 over 24 equals CD is 13, ST happens to be X, and DB is 5, and TR is 10. Now, as you're looking at this, we want to find the value of X. So what I'm going to do here is I'm going to, first of all, I'm going to see if my scale factor is going to be the same. So when I reduce these two fractions, 12 goes into both of those, that's 1/2. 5 goes into both of these, that's 1/2. So now, I don't want to use all three of these. I'm just going to use 2. So I'm going to say 13 over x equals 1 over 2. Now, this is just a proportion. How do I solve a proportion? I'm going to cross multiply and then divide. So when I cross multiply, I get 26. And when I cross multiply here, I get 1x. Well, in this case, x happens to be 26. Now, does that check? If I check, 13 over 26 had better reduce to 1/2. Well, they both go into 13, and that works fine. So this guy right here is my answer. X is 26. Okay, this concludes section 7.2 part 1. Make sure you finish your WSQ when you are done watching the video.